What's up, my pre-calc people? Michael Princhuk here. Before we begin this video, don't forget to hit that subscribe button. It helps me out a lot. Now, in this video, we're going to be working on some practice multiple choice questions to make sure you're going to be ready for the AP Precalculus exam. Now, this is part 2 of a couple of videos I'm going to have that go over different multiple choice questions. Now, here's what you're going to do. You're going to watch the video. When a question pops up, you're going to hit pause. You're going to try the question on your own and hit play to see the answer. Now, if you get the answer correct, feel free to just move on to the next question or keep watching as I explain how to do the question. All right, these questions are designed to be very similar to ones on the actual AP Precalculus exam. That way you're doing some really good quality practice. But if you want some more good quality practice, please check out the Ultimate Review Packet for AP Precalculus. In that Ultimate Review Packet, there are 2 full-length practice exams with 28 multiple choice questions where you cannot use a calculator, 12 where you can, and 4 free response questions designed to be just like the AP exam. And then there's a second full practice exam as well with another 40 multiple choice questions and 4 free response. And you can also check out the Ultimate Exam Slayer that's built to look just like the actual AP exam in Blue Book. And it has another set of multiple choice questions and 4 free response. So if you're looking to do more, check those out. But let's dive into some practice multiple choice questions right now. And here is question number 11. All right, the correct answer here is D. All right, let's talk about why. Well, the first thing we have to do is, well, take our function g and make it greater than or equal to 0. Okay, great. That's pretty easy. Here it is. Not too bad. Now we have to factor it to try to figure out what our zeros would be. And hopefully that's not too bad of a factoring problem. X squared minus x minus 6 is x minus 3 times x plus 2. Now, what we need to do to solve an inequality is to create a sign chart, right? That's what I call it. A lot of teachers call it the same thing as sign chart. So on that sign chart goes all zeros. So 0, 3, and negative 2. All of the zeros from our polynomial function are going to go on that sign chart. And here they are. Make sure you put them in order, obviously in order negative 2, 0, then 3. Now what we can do is actually kind of 2 ways you can do this. One way is to just start testing out values. So here is what we're testing for. Remember, we're looking for values that are positive. We want to be greater than or equal to 0. All right, so let's pick a number like negative 100. That would be a number below negative 2. Again, any number below negative 2, like negative 100. So if I plug it in, I'm going to get a negative right here. Negative 100 minus 3 is a negative. Negative 100 plus 2 is a negative. And 3 negatives are going to make an overall negative. Okay, so that means any value down there is going to be a negative. Negative 2 to 0. Pick a value in there like negative 1. That's going to be right here. It's going to be a negative 1. Negative 1 minus 3 is negative. Negative 1 plus 2 is positive. 2 negatives and a positive is going to make an overall positive value in that interval. All right, 0 to 3. Pick a number like positive 1. Plug it in right here. We get 1. 1 minus 3. Well, 1 is positive, sorry. 1 minus 3 is negative. 1 plus 2 is positive. So we get 2 positives and negative. That's going to make an overall negative. And then any value after 3, like 27, is going to be a positive, 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 which makes an overall positive. So where are we greater than or equal to 0? That's going to be from negative 2 to 0. Notice the brackets because we are allowed to equal negative 2 and 0. And then from 3 to infinity. So of course, that's the correct answer that we came up with right there. But what's another way we could have done this problem, perhaps a lot easier? This is a cubic function, right? If I were to multiply that, we get an x cubed. It's a cubic function with a positive leading coefficient. That means that the left side is down and the right side is up. So I instantly know that the left side is down in the negatives, the right side is up in the positives. Now, I can also look at the multiplicities. The multiplicities of all 3 of my zeros are odd. They all have one multiplicity or multiplicity of 1, which is odd. That means that on each side of these zeros, we're going to alternate. So on the left side of negative 2, we already know we're negative. That means the right side's positive. If the left side of 0 is positive, that means the left side is negative. And that also makes sense for 3 because each side of 3 is going to be opposite signs based on that rule that you should have learned in Unit 1 as well. So I know that got a little bit messy there, but hopefully you understood one of those 2 ways to know where we're positive, where we're negative, and that's going to create our correct answer of D. All right, and here is question number 12. And the correct answer is A. All right, let's talk about why. Remember, with a polynomial function, to figure out end behavior, we need to look at the leading term. So all we have to do is multiply the 4x times the x and then times the back negative x, and that's going to give us a leading term of negative 4x cubed. Now you can multiply the whole thing out if you want to, but it's a waste of your time. You just need that leading term. Now this is odd. An odd degree means one side's up and one side's down. Okay, which one is it? Well, negative leading coefficient means that the right side is the down and the left side is the up. So that's how we can figure out the end behavior very, very quickly. So the end behavior as x increases with that bound to the right is going to be down towards negative infinity. And let's take a look at question number 13. Now, this question will require a calculator. Go ahead and try it out. All right, the correct answer is D. Now, this is a tough one, but basically we asked to find the average rate of change, and that's not too difficult, but it is when it comes to polar, because there's a little bit more room for mistakes. So the first thing we have to do is we got to get our points. You know, we're asked about finding the average rate of change from pi over 6 to 2 pi over 3, so we have to figure out the outputs for those inputs. And that's not too bad. At pi over 6, we get 9/4. And now know for polar how we kind of write it backwards, right? The input goes in the back position and the output R goes in the front position. So pi over 6, the output is 9/4. And for 2 pi over 3, the output is 3 radical 3 over 4. Now, I understand that some of you might be like, okay, how did you get those? So let's actually go back and walk through that real quick. So first, we're going to plug in pi over 6. So we have 3 times sine of 2 pi over 6. Because if we're going to plug in pi over 6, we've got to multiply by 2. And 2 pi over 6 is pi over 3. So we have sine of pi over 3. And use your unit circle if you need to. Sine of pi over 3 is radical 3 over 2. Then we have cosine of pi over 6. And cosine of pi over 6 is also radical 3 over 2. So when we multiply all this together, on top we get 3 times 3, radical 3 times radical 3 is 3, divided by 2 times 2 is 4, and that's of course how I got that 9/4 when I plugged in pi over 6. All right, now let's do the exact same thing, but this time we're going to plug in 2 pi over 3. So we have 3 times, now when I plug in 2 pi over 3 right here, it gets multiplied by 2 and turns into 4 pi over 3, and sine of 4 pi over 3 is negative radical 3 over 2. And then once again, I'm going to plug 2 pi over 3 into right here for cosine. And cosine of 2 pi over 3 is negative 1/2. So multiply straight across the top, I get a positive 3 radical 3. And straight across the bottom, I get a 4. That's how I got those two outputs. Okay, now we have to remember how to find average rate of change. Average rate of change, just to keep it simple, is subtracting your outputs over your inputs. Very easy. So here I go. So 3 radical 3 over 4 minus 9/4 is 3 radical 3 minus 9 all over 4. In the denominator, I'm going to subtract my angles, which are my inputs. 2 pi over 3 minus pi over 6, and that is, of course, pi over 2. And this is where you might want to grab a calculator to do some of this math for you. But when you do all the math, when it all dust settles, we get negative 6.05, excuse me, negative 0.605, which was choice D. So a pretty good problem, but it allows you to make sure you practice finding average rate of change with polar coordinates. All right, let's take a look at question number 14. And the correct answer here is C. Now to get this one right, we have to do long division. We're taking 2x cubed. Now notice there's no x squareds. And if you remember maybe all the way back from Algebra 2, we've got to put a filler. We've got to put a 0x squared in that spot for long division. Minus 5x plus 2 all divided by x squared minus 2x plus 1. All right, here we go. We're going to figure out how do I turn an x squared into a 2x cubed. I'm going to multiply it by 2x. So I'm going to put a 2x in my x column right there. Now I'm going to multiply x squared times 2x is 2x cubed. Negative 2x times positive 2x is negative 4x squared. And 1 times 2x is 2x. Now here's the one part that I have found the most students make mistakes. They don't know what to do now. Subtract. I always circle that minus sign so I always remember to subtract. 2 minus 2 is 0x cubed. 0 minus negative 4 is positive 4x squared. Negative 5 minus 2 is negative 7x. And then I'm going to drop down the 2. All right, now I'm going to ask myself, how do I turn an x squared into a 4x squared? I'm going to multiply by 4. So I have 4 times x squared is 4x squared. Negative 2x times 4 is negative 8x. 1 times 4 is a positive 4. And now I'm going to subtract again. Be careful. 4 minus 4 is 0. Negative 7 minus negative 8 is going to be a positive 1. X. 2 minus 4 is negative 2. Now, at this point, I can't go any further because I can't go backwards. I can't turn an x squared into an x. So I'm done. This is my quotient. This is my remainder. So make sure we choose C as the correct answer because 2x plus 4 is my quotient. But the same question could come up on the AP exam and they ask for the remainder. And in that case, the answer would be x minus 2. So be very careful with that one. All right, and here's question number 15. And the correct answer here is A. So we're doing another inequality here we have to solve, but this time it's a rational inequality. So we're going to take our rational inequality, 2 times x plus 2 times x minus 4, all divided by x minus 3 squared, and we're going to make it less than or equal to 0, which means we're looking for where we are going to be at 0 or below 0. Look, we're looking to be negative or 0. All right, so the first thing we have to do is we got to create our number line. We got to create our sign chart. Now, any value that makes numerator or denominator 0 goes on the sign chart. So we have a negative 2, that's going to make the numerator 0. We have a 4, that's going to make the numerator 0. And we have a 3, that's going to make the denominator 0. But they all go on the sign chart. Now notice I put filled in dots at negative 2 and 4 because we are allowed to equal 0, and negative 2 and 4 will turn me into 0, which is totally cool. But I'm not allowed to be 3 because 3 produces a 0 in a denominator, and you're never allowed to have that happen. That's actually going to be a vertical asymptote. All right, so now we have to go ahead and do our sign chart by picking some values, doing some test values. So pick any number below negative 2, like negative 10. Now I have to plug it in. If I plug in negative 10, now this 2 is always going to be positive, so I mean you can put a little positive right there if you want because it's just always going to be positive. But if I plug in negative 10 here, I'm going to get a negative. Plug in negative 10 here, I'm going to get a negative. And now be careful at the bottom because when I plug in negative 10, I do get negative 13, but I square it. So that bottom is always going to be positive no matter what because it's squared. So 2 negatives is going to make an overall positive value down there. All right, pick a number in between negative 2 and 3. Really easy one to pick is 0. That 2 is always going to be positive. 0 plus 2 is positive. 0 minus 4 is negative. And in the bottom, 0 minus 3 is negative, but it's squared, so it's always going to be a positive. So values in between there are negative. All right, pick a number between 3 and 4, like 3.5. So we have a positive 2. 3.5 plus 2 is positive. 3.5 minus 4 is negative. Be careful. And again, in the bottom, it's squared, so it's always going to be positive. And that's going to create a negative because there's, well, a negative there. All right, and then any value above 4, like 27, that's going to be a positive 2. 27 plus 2 is positive. 27 minus 4 is positive. And again, that bottom is squared, so it's always going to be positive. That's going to be all positives. Now, we got to be very careful giving our answer because remember, we want it to be less than or equal to 0. That means we like being negative. So most kids are going to say, oh, the answer is easy. Negative 2 to 4. From negative 2 to 4, we're always negative. But we have to skip 3. The reason we have to skip 3 is, remember, we want to be less than or equal to 0. Negative 2 and 4 will equal 0, but 3, there's nothing because of a vertical asymptote. I'm not allowed to have 3 in the denominator. So even though I'm negative from negative 2 to 4, which makes sense, I have to skip over 3 because nothing happens at 3. And that's why my answer is negative 2 to 3, and then again from 3 to 4. So hopefully that makes sense. I tried to make that a little bit tricky to make you think a little bit. And moving on to question number 16. And the correct answer here is B. Now, this is actually a really tough one. So we have the points of a sinusoidal function. I hope by now everybody knows what a sinusoidal function is, right? It's a function that's going to look like this. And it could be a sine graph or a cosine graph. Sinusoidal doesn't mean it has to be sine. Now, this particular one is, though. So we have the amplitude of 4 and we have the midline of 50. We know that for sure. That, of course, comes from right there and right there. Now, that means the midline's at 50. We go up to our max of 54, down to our min of 46. But we also, this is a negative sign right here. That's going to be a reflection across the midline as well. Now, they want us to find the B and C value. Now, in my opinion, to make this problem as easy as possible, I think it's wise to actually draw a picture. This is just how I process it. So here's a sinusoidal function, and we can label the points that were given to us. So we know that the max, the first max is at 5,54, then to the midline at 950, and then to the min at 1346, back to the midline, back to the max, back to the midline, back to the mid. Now, the first thing we have to figure out is what is our period length. Now, we know 2 pi divided by the b value equals your period length. So if we could figure out the period length, we could solve for b. So a couple of different ways to find the period length. You could look at the distance between any 2 consecutive mins or any 2 consecutive maxes. So if we look at the distance between these 2 maxes right here, that's 5 to 21, that's a distance of 16. Or we could look at the mins, 13 to 29, that's still a difference of 16. So we know that the period length is 16. So now we could solve for b. So the first thing I'm going to do is multiply the b to the other side. Then I'm going to divide both sides by 16, and we get pi over 8. So we can immediately get rid of that one choice that had a b value of pi over 4. We know the period is 16, which produces a b value of pi over 8. Now we have to figure out the c value. And this is where it gets a little bit tricky. First, it is a sine function. So when we want to think about that sine curve, a sine curve goes like that, right? So we want to find that sine curve. But here's the most important thing that's going to trick a lot of kids on this problem, is that the a value is made negative, means there's that reflection. So this is actually not the curve we're looking for. This is the curve we're looking for that goes down first. So you can always, all sine curves have to start on the midline. So we could start right here, we could start right here, we could start right here. Now, we can't start at 5 because 5 is starting at a max, and that's what cosine would do. We don't want to start at 13 or 21 or 29. We want to start at the 9 or the 17 or the 25, or we actually could come back here and even start at this point because we could figure out that previous point would be. That would just be going backwards, 4, which would be 1, and that would be at the midline of 50. Now, the problem is I don't want to start right here because notice that that sine curve goes up first. So a lot of kids might choose a c value of positive 1. Well, not positive 1. Oh my gosh, I'm so sorry. Remember, this is to the right, right? 1 would be shifted to the right, and that's going to be a c value of negative 1. That's a huge thing. I don't want to mess that up. But the problem is that if I start my sine curve there, that would be a sine curve with a positive out in front of that a value because it goes up first. We don't want that. So here's actually where we want to start this. So we want a c value of negative 9. That's going to move the starting point right 9, and that's going to be starting the curve going down first, which is what that negative on the a value is going to do to us. We could also have a c value of negative 25 starting right here, but that wasn't one of the options. So the correct answer is going to be that b value of pi over 8 with that c value of negative 9. That's a really tricky problem. Hopefully you really pay attention to that and understand that, because one like that could definitely come up on the exam. Now for question number 17. And the correct answer here is D, 2x plus 5. So the question asks us to find the equation of the slant asymptote. Now, to understand how do I even know that I have a slant asymptote, we got to think about end behavior of a rational function. To determine end behavior of a rational function, you take the leading term of the numerator divided by the leading term of the denominator. And when we do that, we reduce to 2x, which is a polynomial function. And the rule says that once you divide your leading terms, if you get a polynomial function, the end behavior of your rational function follows the end behavior of that polynomial function. And this being an odd degree with a leading coefficient that's positive, that means the right side's up and the left side's down. Now, you might be like, well, wait a minute. Well, this question's not asking about end behavior. I know, but when you get that resulting polynomial, when you divide your leading terms, because it's linear, that's the red flashing light that tells you that you have a slant asymptote. Again, when you divide your leading terms and you get a linear polynomial, that means you have a slant asymptote. And one more piece of information we know is that our slant asymptote is going to be parallel to this linear polynomial, which means we're going to have the same slope of 2. Now, unfortunately, that's not going to help me decide because all 4 answers have a slope of 2. So to get the final equation of the slant asymptote, I need polynomial long division. So I'm going to take 2x squared minus 3x plus 8, and I'm going to divide it by x minus 4. How do I turn an x into a 2x squared? I need a 2x. X times 2x is 2x squared. Negative 4 times 2x is negative 8x. And now here's the one thing a lot of students mess up on is we have to subtract. Remember, I write that minus sign, I circle it so I don't forget. 2x squared minus 2x squared is 0. They're gone. Negative 3x minus negative 3x turns into a positive 5x. Write that out if you need to. Negative 3x minus negative 8x. You'll see that 2 negatives will turn into a positive, and negative 3 plus 8 is positive 5. And I'm going to have that 8 down as well. Now, how do I turn x into a 5x? I'm going to add 5, or I need a 5. X times 5 is 5x. Negative 4 times 5 is negative 20. And once again, I'm going to subtract. 5 minus 5x is 0. 8 minus negative 20 is 28. Now that's my remainder. The remainder is not needed at all in terms of slant asymptote. The quotient is all you need. So 2x plus 5 is the equation of my slant asymptote. All right, and moving on to question number 18. Here it is. And the correct answer here is B. And this is one that a lot of students can mess up if they don't remember their transformation rules. So first, we see a minus 5 on the outside. Minus 5 on the outside. Anything adding or subtracting on the outside is a vertical translation. In this case, it's going to be true to what it says. Minus 5 means it's going to go down 5. So we can immediately get rid of D and C because it's not a vertical dilation. That's multiplication on the outside. So the other thing is that 4 on the inside. That 4 on the inside is going to be a horizontal dilation, but this is where it's tricky. It's by a factor of 1/4. That'd be the reciprocal of the value inside there. Whereas, let's just say that there was a 4 out in front, that would be a horizontal, or that'd be a vertical dilation by a factor of 4. So on the outside, it's true to what it says. But on the inside, with that B value there being 4, that's a horizontal dilation by a factor of 1/B, which in this case is 1/4. So what we get here is a vertical translation down 5. That's because of the minus 5 on the outside. And then because of the multiplying by 4 inside on the X, that's that horizontal dilation by a factor of 1/4. So as long as you get those things straight, that'd be a pretty easy question. All right, question number 19. Here we go. And the correct answer here is D. Now, this is one that's going to really make sure that you know your rules. All right, so we have this function g that we see in the graph here, but it says a second function h is only defined. It's the same as g, but it's only defined on the interval -6 to 3. So I'm going to color that in with a different color here. So here's -6, and we're going to follow this, and it's the exact same. It's right on top of it, but it only exists from -6 to 3. And the question is, how many extremas are there? How many, oh, that's a typo right there. I should say how many relative extremas are there. So hopefully you caught that. Sorry about that. So here's what we got to remember is most kids are going to say 3. They see this one right here, that relative min, this one right here, that relative max. They even see this one right here, that's a true min, but a absolute min is also considered a relative min. So the answer is 3. But that's not the right answer. That's because when you have a restricted domain, endpoints count as relative extremas. So this endpoint right here and this endpoint right here on function h, those endpoints count as relative extremas, and that's where we get 1, 2, 3, 4, 5 from for our final answer of 5. So hopefully you remember that. And if you didn't, hopefully I caught you and you're going to be able to get a good question right on the multiple choice exam. All right, and final question, number 20. Here it is. And the correct answer here is B. Now, what you should first recognize is this sine, cosine. You're thinking, okay, what trig identity does that kind of look like? Well, it's this one. Sine of 2x equals 2 times sine of x cosine of x. Now, that's not exactly what this is, but we could kind of play the game here. So we know that basically whatever value's in here is going to be over here, it's going to be half of it, right? So that was 2x, half of it's x and x. Or whatever value's here, it's going to be doubled on the inside. So essentially what I see here is that the reason why B is correct is because if I have 4 sine of 6x, and I'm going to follow this same principle here. The first thing that's going to happen is this 4 right here is just like a constant out in front because it doesn't really do anything, right? Because in the original problem, there's no constant right here. So we're just going to leave that 4 there for a second. And sine of 6x. Okay, well, that is 3x times 2. Right? That's that double angle. It's 3x times 2. So the 2 comes here, and we get 2 sine of 3x cosine of 3x. Now the 4 and the 2 on the outside is where the 8 comes from, and then there's the sine 3x and the cosine 3x. So we have the 6x on the inside, but again, half of that goes here. That's the 3x and the 3x, or the other way around. The 3x gets doubled, makes a 6x, however you want to look at it. But that's why B is the correct answer. And that can be really tricky. Like I honestly remember a lot of my students having a problem with this as well, just trying to see that and understand that. So just really take your time to make sure, even if you just go through the choices and walk through it, when you get to B and you think about, once you recognize that this is a double angle formula, we need that double, right? So there's that 2 times 3x that makes that 6x. Now we can follow that double angle formula, which is going to be a 2 sine of the 3x cosine of the 3x, and then of course to form the 2 is where that 8 comes from. So I know that I went through that twice, but I really wanted to make sure I explained that because for a lot of kids that could be tricky. All right, that's it. Hopefully you enjoyed these questions. Hopefully they're going to help you do really, really well on the AP exam.